share the screen. So this is our first lecture, which is introduction, chapter number 1, this one. All the materials I have added here, all the materials, whatever you can see, all the pictures, all the slide, all the text, information, most of the information, not all, I have added from this chapter number 1, from the book, of course, because this is our textbook. We should go to page number 1. From here. In your version of the book, whichever I have uploaded, you can see in that book there are some marks. I actually have some marks for just to identify or just to show that where actually I get the information from. Right, so it will be helpful. I think it will be helpful if you just follow the marks as well. Some of the marks show you the specific definition, whatever we are going to discuss. Right, so this is our chapter 1. So let us start. So we know that yesterday we have said the assembly language is a low-level language, and it is system dependent. And why it is system dependent? Because whenever we write a code in any assembly language, in assembler or in any simulation software, we always need to think about, we always need to consider about which system where we actually writing the code. Because the code depends on entirely based on the system. For example, if I want to write code in my system, I have to consider that what is my processor, what is the memory, how was the memory, how was the data bus, how the memory architecture we are using here in the system, and then so on. So considering all this, then you write the code. And if you want to implement this code, or if you want to run this code into your system, it might not work, because your processor may be different, your memory architecture may be different, your data bus or the system bus or the control bus, the width of the bus may be different. So that's why we say that the assembly language is system dependent. So it totally depends on the system. That's why before we start the coding of this assembly language, we need to know our system very well. That's why chapter number 1, 2, and 3, all of them, basically all 3 chapters totally related to our system. Because if you know your system very well, you can write the assembly language very well as well. All right, let's say from chapter number 4, we start writing the code. Although we have some code here, as just for an example. Just for example, we have code here, very, very simple. Here, just for an example, that how we write the code. All right, so this is just an example, but originally we start writing the code from chapter number 4. After knowing our system very well, after knowing our computer architecture, processor architecture, and memory architecture very well, and then we are going to write the code. Okay. All right. Let us discuss about our system. I hope you know this image very well. This is a very common image, very common. And this image used in at least 3 to 4 courses. The same image actually used in 3 to 4 courses, like assembly language, microprocessor, computer architecture, operating system, maybe other one as well. So look at the picture. And by looking at it, tell me whatever you have understood. I will explain it, don't worry. But it is better that you actually try. Look at it. We have some levels. We have some other indication. Look at it, try to understand, and let me know whatever you have understood by this. This is a very common one. As I said, at least 4 courses. In 4 courses, you will see this same image. Whenever I take the other 2 courses like operating system and computer architecture, I have used the same image. And most of the book of those courses uses similar type of picture. So look at it and let me know what you have understood. Anyway, let me give you 30 seconds or 1 minute. Look at it and try to understand. No need to jump for the conclusion. Right? Try to understand. Think about your system, your computer, and then let me know whatever you have understood. The answer can be different, but I need to listen from you. It is always better not to just listen from me. I have to also listen to you as well. So let us try. You can start from level 5 to level 0 or 0 to 5, whatever. Yeah.
If we go through level 3, up to level 3, 0 to level 3, so it is saying that it's system dependent.
Okay.
Okay, so that means this is not an independent language. But also, isn't all the programming languages are system dependent?
And that's why I'm asking you. Look at the picture very well. Look at the picture very well. Look all the levels. Try to understand. There are some examples given as well. Look it very closely. Think. Try to think. Every text they have used here, by the way, this is from the book. Every text they have used here, they had some meaning. They got some meaning, right? This one, this arrow, that one. The levels, upwards or downwards. Okay, anyone? Anything? Can anyone just tell me that what we have understood by this?
Sir, I think from level 0 to level 3 is system dependent. Means that when I put any input, then it is going to work as a system. Like what is my system RAM, my processor, and after this level 4 and 5, it is going to do in every computer as the same way, I think.
Okay. Can you give me example? Each of the level, you are right. Each of the level, you can give me example. The level 4 and 5, they have given example. You can see that these are the example. Each of the level also have some example. Can you guess the example? One thing. Try to match whatever you use in your daily life, in your system, and with this information. It will be always better that you match with your daily life experience with the knowledge you are getting. Then it will be much more clear and easier to understand. All right. So whenever we are checking from level 0 to level 5, you can match each of the level with your daily life or daily uses of your machine, of your computer, of your application, and everything. All right, so you're right. So can you please, or anyone else, can you give me more details or at least one or two example of each of the part?
So can I try?
Sure, of course, try.
First of all, this is the overview of a computer system where the shows that this is the instruction increase the level of abstractions, and in the level 5 we use that as a limited user we use these applications such as like many applications we use here. The example is spreadsheet and WordPress, and the level 4 is shows that high level program language where we done as a problem solving like on a many language. Here is C and Java, and this both level 4 and level 5 is a system independent. This is that shows that user friendly application where we use, and where the system independent we're using the level 0 to level 3. Here we level 0 that shows that hardware level for our system, and in the system we are using the level 1. We are attaching our running our OS running our OS. This is shows on level 1, and level 2 that we have running a machine language level where we compile or something interpreter, and level 3 where the assembly language level. So these are the system dependent. So this is the overview of a computer system.
Yeah, very good. Yeah, fine. Thank you. Thank you very much. Yes, right. You're correct. So, yeah, fine. Anyone else wants to try? Yeah. Exactly. Yes. Very good. I actually want this one that you should use your daily life experience. The Zoom app you are using, this is in level 5, right? Very good. Yes. Okay. Wait. The Zoom app, wherever they are using the application, it's not necessary they transferred it into the assembly language. This is completely different language. It's not necessary. Yeah, but it is not necessary that it will convert it into the assembly language. It actually can directly go to the operating system and the hardware level. It is not necessary that all the applications are related to these two parts. It is not always necessary. But okay. Don't think about that. This is just a step by step that all the process using the same. It's not actually like that. It is actually showing that some of the steps, some of the portion, or some of the components of our system. All right. It's not necessary always that all the applications follow the same levels. All right, because all the applications are not converted into the assembly language. All right. Okay. Fine. Anyone else? Okay, fine. Anyone else wants to discuss about this system dependent? And my question is, you are right that you are saying that system dependent, system independent. And I have two questions to you. One question is, what do you mean about the system dependent with a real life example? And why from level 0 to level 3 they are system dependent, and why level 4 and 5 is system independent? Whereas, again, same question: what do you mean by system independent? I will explain everything, but I'm just trying to listen from you first. First question: what do you mean by system dependent? With an example. Just tell me whatever you have.
Since used by the machine or the system, if we are talking about operating system, some of the computers have Windows, and some other computers have Windows 10, like 7, 8. But if we talk about Linux or something else, we have to install it. Uh, I mean to say,
Yeah, I understand your answer. I understand, but the answer is slightly different. Okay, yeah, it's okay, fine. Thank you. Ronnie, please listen to us. Sorry, listen to us. Any other observation about the system dependent? Why we call this zero level to why they are system dependent?
Sir, I think system independent, I think it
No,
means
I'm asking about system dependent first, right? Okay. Yes. Exactly. Okay. Level 0 to level 3. Okay. Anyone else? Please try. At least try. I can just see that only 4 or 5 students are answering the question, not the rest. Please try, rest of you. At least try. No problem. There is no shy or no problem with giving me any other answer. No problem. I accept all the answers. Please try.
so
yes, sir.
Yeah.
We think about the levels of 0 to 3, I mean the system dependent part. System dependent is actually processed with the hardware. I mean, this is almost fixed with a particular hardware system. So that is why it is called system dependent.
Can you give me an example? Example.
Yes, sir.
Example.
Any dependent example would be
think about your system you are using every day. Think
so
about, yeah.
There are some in the processor. There is an operating system working there. Not Windows, the processor's operating system, which is the most of the programs after that point is actually fixated with that operating system. I mean, that is not changeable. That is actually dependent on the system.
Yes. System dependent.
The commands are reliant on the current platform to support it. Like in Unix or Linux command, there are certain commands that will not run on Windows unless we really have that exact commands installed on like that. And
so when we say dependent means whenever you do some activity on any other level, at language practice level, if you want to do any kind of activities, these activities will entirely depend on the system. Your might not work because the activity, the process, the coding, and all the instructions entirely depends on the system you are currently using. For example, I told you previously as well, if you write a code in assembly language, or if you have a machine language code for my system, and if you take the code and try to run it into your system, it might not work because we know that assembly language code is system dependent. That means this code for my PC will only work in my PC. It might not, I said might not, I don't say that it will never work. It might not work in your system because your system and my system might not same. If your system and my system is exactly same, then it can work. But if it is not same, let's say your processor is different, your operating system is different, your memory is different, right? In that case, the code I have written in assembly language or in machine language, it will never work in your system because your system is different. That means the code, the activity I am doing in assembly language or machine language or any other tool activity is entirely depends on my system, not your system. That is why it is called system dependent, because it totally depends on the system. Same as the same thing. Let's say you write some of the assembly language code in your PC, right? So whenever you write the code on your PC based on your microprocessor and your environment of the system, and if you give it to me and if I want to run, we want to do the same thing, it might not work. Because whatever you have written in the assembly language is totally depends on your system and it is system dependent. That's why my system cannot work with the same assembly language. Maybe if I want to run the same code you have written in your system, maybe I just need to change a little bit based on my system. It is not that you have to entirely change the code, not really. You just need to change a little bit. For example, you are using one microprocessor where we have a very large register in the microprocessor. Wherever in my computer, I don't have that much large register. So if I just change the processor, the register name or the location, then it can work. Because the name and the size of the register may not be same in my processor and your processor. So that kind of changes we need to do. Most of the time, this is the main problem. The processor, the memory architecture, the data bus, control bus, and the system bus, the width of that bus, this kind of thing may not be same for all the system. All right? So that is why we call them system dependent. For this, think about I told you, think about your real life application. Let's say about the hardware level. Why we call hardware level as system dependent? Think about this scenario. I have installed my graphics card into my PC, all right? So whenever I attach the hardware to my system, what I do, software, I have to use the device driver software and other software so that my hardware, my processor, my other system can recognize and then so that I can use it, right? Graphics card, and I give it to you. And I told you, okay, this is the graphics card, you can use it in your system. Try to use it in your system. So you plug into your system. Do you think that you can use it without installing anything or without doing anything?
Yes, sir.
No, sir.
No, sir.
No, sir.
Some of the very basic level of the driver, it can be installed automatically by the operating system, because our operating system is now very smart.
Yes, sir.
Right. Some of our operating system nowadays, they are very smart. They detect it and then install it by itself. You actually cannot see that it's actually right corner. You can see that you have a new device and it is installing to use it, right? Have you seen it? On the right, left, bottom right corner. Your device is ready to use, right? Sometimes they say your device is ready to use. What does that mean? Because you have added one new hardware and the operating system and your computer system needs to recognize this new device, needs to install some utility software so that it can be recognized and can be used. Without doing it, it is not possible to use that hardware. Same thing happened, the scenario I have just said. If you have a graphics card, which I have used and I have installed into my system, by installing so many software, device driver software, and so on. And if I give it to you, and if you just plug in, maybe your operating system do some basic installation driver, but maybe not all of them. So because it is installed into my system, so that device, that graphics card will work in my system because it's installed here. My system knows it, but your system still doesn't know it, right? So your system also needs to do the same. Your system, your computer also needs to do all the installation and everything, and then it will work. Otherwise, that device or that graphics card, which was installed previously in my system, but it will not work in your system because it is not installed in your system. That means this is an example that a hardware level is also system dependent. I hope you understand the scenario, right? That hardware is also system dependent. It's actually working in my system. It is not working in your system. It will work in your system if you do a little bit of change.
Like configuration, sir.
Yes. All right. So this is the, yeah.
Sir, I had a graphics card GT730. Then I installed 1050 Ti, but I didn't install any drivers. It was running automatically.
Yes.
But,
yes.
But was it 730 driver, sir?
Whenever you attach the graphics card into your system, I told you nowadays our operating system are very, 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 very smart. Without asking you, they actually installed most of the part. Oh, let me tell you another example. Whenever I use my first PC in 2002, right? Whenever I bought my PC, so they gave me so many CDs. They gave me CD for the motherboard. They gave me a CD for the sound card. They gave me the CD for the other drivers and everything. So many CDs, and I have to manually install all the CD because the operating system at that time, which was Windows 98, Windows 98 version at that time, at 2002, was not that much, smart enough to do everything by itself. So we have to separately install all the utility software. But now in 2020 or 21, our Windows 10 are so smart that if you install anything, it just do all the necessary tasks, most of the part, necessary tasks, without asking you, which is automatically install all the required device driver software. In some cases, if you have an extra CD which actually required to run or to have an extra feature of that device, then you have to separately install it. Otherwise, it is not necessary. Maybe in your case, Mr. Fahim, that the operating system recognizes a new device and it has some utility software related to your device, and then it install it. Some operating system also download from the internet and then install the device driver for you without asking you. So maybe it happens to you as well. So it is actually, there is a name, it's called plug and play. Right, there is a name for that. Now, most of the devices we use nowadays, it is plug and play. I hope you know this term, right? Plug and play. Plug and play means,
Yes,
plug and play means nowadays you don't need to install anything. You just plug it, any device you want. You just plug it to you, to your system. It will do all the installation by our very smart operating system. But 10 years ago, it was not possible. 10 years ago, whenever you buy a new device, you have to install it manually. You have to install every single device, every single driver manually, whenever you have it. So the process, basically, the background process is all same. You have to install something. You have to install the device driver software to use it. But nowadays, this work is done by the operating system. 10 years ago, it was done by the user. That is the difference. You understand? So do not think that operating system is doing the same. That means it's a system dependent. It is not actually, because the background process they do all the installation for you. Without installation, it is not possible to use that hardware. Fine, okay?
Yes, sir.
Any more question? So this is our hardware level. How about the operating system? Think about the operating system. All right, now we have done the hardware level. We have used it every day. How about the operating system? Think about the operating system and why we call them system dependent. Think about the scenario. You are using Windows 10. I am using Windows 10. And most of them are using Windows 10. Then how come it is system dependent? Why it is system dependent? Our operating system. The way I have just discussed the hardware in a system dependent with our real life example, you can do the same. You can do the same, that you think about the operating system and your system, and you also need to think about that why it is called a system dependent. Think, let me know. In the meantime, let me close the...
Sir, I don't know you will like my answer or not. I think it's written in the native language, and that's why.
What do you mean by native language?
Sir, like low-level language, sir.
Okay, give me answer in a way that everyone can understand this.
Sir, that's what I can understand till now, sir. Thank you.
What is it again?
Sir, it's in the machine can understand the language, native language, and that's why, sir, it's system dependent, sir, and it can run on the CPU, sir.
So let me ask you, whenever you download the Windows 10 from Microsoft website and then you install it, it is the same software is using by your friend and me. And how come it is system dependent? If you have a software, downloaded software of Windows 10, right, like 2 GB or 3 GB file, if you share this one to the other friend, it will run. If you share it with me, if I install the same version you are using, it will run. Right? Same software, right? Same file. If you have a different activation key, if I have a different activation key, so it's activate myself. That is different thing. But the same, so from same source you get the software, and we install it with the same software or the same file. Then the question is, how is it system dependent? If it is working in, because the same, remember the Microsoft in a website, they have one, let's say just one version of the Windows 10, the latest version, and it is downloaded by millions of billions of PC. So millions of billions of PC using the same file, install it and run it, right?
Yes, sir.
So how is it system dependent? I hope you understand my question.
Yes, I understand your question.
So it should be, according to the example, that if it's running everywhere, according to that example, it should be system independent, like C or Java. But why it is system dependent? Why our operating system or okay, they say operating system calls, that means the operating system activities. Why it is system dependent? Why this operating system is not here?
Sir, it's because, sir.
Yeah, try. Don't worry.
Sir, is it because it runs through the system, sir?
Is it because of what?
It runs through the system, sir. Like we can change settings through the operating system, sir. And
Sir,
Yeah.
the programmer.
Yeah, try. Yeah.
The programmer are configured by a system, operating system, that if anyone can install their operating system, they are manually do that in a low level, like 30 bits operating system or 64 bit operating system. So this operating system are installed by these memory access locations. they're like 32-bit and 64-bit. So so this system is already installed, programmed by a programmer. So if everyone, so anyone can run his software like Windows 7, 10, or Linux. So it is installed in this system. So this is called a system dependent.
Okay. Very close, very close. Yes, try. Yes. Exactly. Yeah. Exactly. Yes, Mr. Shakil Ahmed, you actually gave me almost very close to the correct answer. Yes, correct. You're absolutely right that whenever we download the file from the Windows, I mean from the Microsoft Office, that file is same. But whenever you install it in your system, I think you know that operating system make an environment, and so that all the hardware and the software can run together. It's just making an environment. So whenever that the same file is creating the environment, right? That environment is only true for your system. And whenever you download, whenever you install your operating system and your operating system make an environment, it is only based on your system, right? So it's making one environment based on your system. Same downloaded software, if I using it into the other PC, it will also do the same. It will create another environment by the operating system, which entirely depends on that system. So that environment and this environment, they are not same. That's why the operating system, that's why this operating system code, that means operating system activities. The way we are using the operating system in my PC is not same the way you are using your operating system in your PC, because your PC is different. Because my PC, let's say my processor is 96 Core i5 Intel 9600K, right? So it's 3.8 gigahertz. Maybe your one is Core i9 or Core i7, right? Maybe it's the 10th generation, 100040, right? So processor is different. The environment should be different, right? So whenever you install the operating system and whenever the operating system making the environment in your system, it is entirely depends on your system. And that system is not same, absolutely not same to the other system. So that's why we call them system dependent. That's why if you plug out any hardware from your system, because your operating system knows how to control that hardware. And that's why if you plug out any, let's say your graphics card and then plug into the other system doesn't know this, this new device. They need to install it again. Although that same hardware is working on your system because your system already know it. So that is the difference. And that is the reason that operating system is also, operating system activities, also system dependent, right? Don't get misunderstood that we are using the same file, like other software, we are using the same file, but it is actually the way they are using or the way we are doing the internal activity, they are totally different. That's why we call them system dependent. Fine, okay? So it is, and if you understand assembly language and machine language, they are actually the same thing. That we need to write a code for very specifically for your system, not other systems. So if you want to run the same code into other system, you need to change a little bit based on the other system. Fine, okay? I hope.
Yes, sir. Yes, sir.
All right. What is the problem? Mr. Shabujur Rahman, what happened to Mr. Shabujur Rahman? All right, fine. Any other question? So think about it. Okay, do not just listen. Why I'm asking to you and why I'm getting the answer to you, because whenever you listen so many perspectives, it is much better. And please participate in the class. I can see you thank you very much for some of you who actually participated, but I expect more students to participate during the class, because if you participate, it is better for you and for us. Maybe you have a better understanding. Maybe you have a very good way you actually giving the solution. As Mr. Shakil says, that operating system is a bridge, is like a bridge between your software and your hardware. So whenever you're making the bridge, whenever you're making the environment, it should not be same for all the systems, right? So good insight. So that's why please participate, and it is always better. And same way from today is day number 2. From day number 2 until the last day of the semester, whenever we learn anything, whenever we try to discuss anything, please match this one or match this information or knowledge with your daily life use. I don't want that you just blindly memorize and write it in the exam, or blindly memorize and tell me during the Viva without knowing anything. That is another problem. Most of the time, whenever I ask any question from the Viva, let's say, what is assembly language? What is system dependent? Why it is called system dependent? You memorize something from the book or from slides or from somewhere, you just tell and just give me the answer without knowing it, that what is actually you are saying. So please don't do that. For that reason also, you can get less marks. It is very easy to detect that whether you understand whatever you are saying or not. So please, this course is very related to your daily uses equipment, your daily activities. If you can match it, it will be interesting, it will be easy, and it will also be understandable. But if you just blindly memorize, obviously, next day you will forget. Right? So please try to do that. Do we have time? More time? 10 minutes. Okay. We have 4 or 5 minutes before we go for attendance. How about the system independent? If you understand the system dependent very well, or at least have it like slightly understanding. So can you, exactly same way, can you give me the explanation of the other two, system independent, level 4 or level 5? I expect answer from the students who have not answered me yet. Please try. Why and what is system dependent for level 4 and level 5?
It means that it can be run in any operating system and in any PC without unlike the system dependent software.
Not clear whatever you are saying actually. Let's think about. No, not you. No. Listen. Yeah. Shakil Ahmed, fine. Thank you very much. I'm expecting answer. You're correct. I'm expecting answer from the others. Others, please give me answer who have not answered me yet. There's so many students who have not answered me yet. Anyone? So many. We have 36. Anyone who wants to tell me that why we call system independent? Let's think about C programming. Whenever you do coding in C programming, do you need to change that code to run in another system?
No, sir.
No, sir.
No, sir.
No, sir.
Why not?
No, sir.
Why not?
Because C is a basic level of language and most of the PC will run it effortlessly without any kind of hassle.
Why? How?
because that language doesn't put that much of a pressure for any kind of PC and
no.
so
Not really.
then like PHP or HTML, they are also independent languages, right?
Yeah.
C is the mother of programming language. That's why.
No. No. That's not the reason. That is the reason.
High-level languages are system independent, means sir, it's platform independent. Sir, we can if we use Zoom, sir, that's written in sir high-level language, and we can use it on Apple device and our Microsoft operating system. Every operating system we can use this. So that's a reason it's system independent.
Okay. My specific question is, whenever we write a code in C or Java, you have done C, so let's talk about C. Whenever you have to write a code in C, you don't need to change that C code to run into the other system. Because this is system independent, it can run anywhere. But my question is, how is it possible? Without changing it, how it can run in the other PC? In the same case, in assembly language, if you write any code in the assembly language, you have to change a little bit based on the new system. Okay, but in C, you don't need to change it. Why and how? Or why we know that why, but how?
So because it is a cross-platform language. I mean, C, C++, these are cross-platform languages. Like if you write the code in any computer or any system, and we can run it through all other systems only. So this is how the systems are working. I mean, my main point is that C and C++, I mean, the similar kind of high-level languages are cross-platform language. So that is why actually we can run it on.
From the language means the system independent. Same answer, but my specific question is how.
So can I?
Yes. Whenever you write a C program in one PC, you're actually using a C compiler, right? Which can compile and interpret, and then it goes to the other level to run the code. Whenever you take that C code to the other system, right, you don't need to change it, because if that system has that compiler, C compiler, of course, whenever you have a C compiler, so if you have the same C compiler into the other system, right, that compiler again same will compile it and then make it understandable by the operating system and by the other system. So the compiler, if you have that compiler, it's the compiler's responsibility to make it understandable to the system, any system, right? So it is done, it is the responsibility for the compiler. But whenever you write the code in the C, you don't need to think about it. You just need to write the code. The rest of the task will be done by the compiler for your high-level coding into the low-level coding, so that our hardware and our operating system can understand, although it's in the different environment. So whenever you install the compiler into the different system, they will make their own environment. So it is done by actually the compiler, not our C programming. So our C programming is still system independent. That is, whatever you write the code, if you have a proper compiler into the other system, it will run, no need to change. All right, so the basic difference is here. Whenever you have an assembly, it also has an assembler, by the way, so that the hardware can understand. But it is totally on the machine. So if you take it to the other machine, it will not work. Because whenever you write the code, let's say you write for loop. For loop is true for all kinds of things, right? But whenever you write a code for the Pentium processor in the assembly language, it's not true for the whole system. So that is the difference between high level and low level language. We will discuss it more. Don't worry, we'll discuss it more. Because we don't have time today, much more time today to do the further discussion. So any other question before we finish? No. Fine, okay. If you don't have any other questions, so let me give you your SMS. So every time, please participate in the class, and not just for 5-6 days. I expect most of you participate in the class. Whenever I ask you a question, please answer me. It doesn't matter if it's right or wrong. For example, if it is wrong, it is also very good that you have given me the wrong answer. Because after giving me the wrong answer, we can clarify. Right, so if you don't give me this wrong answer, you cannot clarify, you cannot correct yourself. Right, so it is better to correct or to do a better understanding. Give me the answer. So you are section C. Right. Section C, today is 8, and we have started at 1:10. Okay. So section C, CSC 197, please respond. Shakil Ahmed. Shakil Ahmed. Mominur Rahman.
Yes, sir.
Saidul Islam. Saidul Islam.
Yes, sir.
Right.
Yes, sir. Yes, sir.
Moinul Islam.
Yes, sir.
Iman Shaukat.
Yes, sir.
Shariar Haq. Shariar Haq. Kadimul Haq Rani.
Present, sir.
Mukid Hassan.
Yes, sir.
Said Mukidul Islam Charles.
Yes, sir.
Shubujur Rahman.
Sir, it's present, sir. It's just disconnected.
Again.
Yes, sir.
Yukon
Network
Kumadas.
Present, sir.
Omid Hassan.
Yes, sir.
Rubel Babu. Rubel Babu absent. Rizwan Ahmed.
Yes, sir.
Ahmed. Okay. Jannati Naim Raha.
Yes, sir.
Imtiaz Tasnim.
Yes, sir.
Shahida Ahmed. Afia Siddiqa.
Yes, sir.
Bahul Debnath.
Yes, sir.
Abdul Sabur.
Yes, sir.
Bohanul Kubir. Bohanur Kubir.
Yes, sir.
Ruwayat Alam.
Yes, sir.
Samuel Rudra Pahan. Lamia Pahan is absent. Lamia Akhtar.
Yes, sir.
Sumaya Islam. Abir Hussein. Fahim bin Shahid.
Yes, sir.
Muhammad Mahbub Alam.
Yes, sir.
Johura Akhtar Min.
Yes, sir.
Nushin Tasnim.
Yes, sir.
Jamil Islam.
Yes, sir.
Shahriar Shimul.
Present, sir.
Tushar Gop.
Yes, sir.
Ashikur Rahman.
Yes, sir.
Jannatul Firdaus. Tahmina Nasrin.
Yes, sir.
Tahmidul Rahman.
Yes, sir.
Khaya Jannat. Rakibul Hassan.
Yes, sir.
Sabiha Parvin. Mehdi Hassan. Mehdi Hassan. Hussein Al Amin Akash. And Abdul Salam. Absent. Anyone else?
Yes, sir. Mehdi Hassan
Mehdi Hassan.
Shazu. I don't know my serial number.
Okay, okay.
Just start.
Okay. Anyone
Mehdi
else?
Hassan Shazu.
Yeah.
Sir, Rubaiyat Alam Bhuya.
Ruwayat Alam, yeah, it's fine.
Sir, Mehdi Hassan Shazu serial number. I don't know.
Yeah, serial number is 41.
Okay, sir. Thank you.
All right. Anyone else? No, maybe. It's okay. Thank you very much, all of you. See you tomorrow. See you tomorrow. Allah Hafiz. Walaikum assalam.
Allah Hafiz, sir. Assalamu alaikum.
Thank you, sir.
I have something to say, sir.
Yeah, yes, okay. What is it?
Sir,
if I'm not wrong, sir, the basic difference between system dependent and independent is if we want to interpret or compile something, if the system himself compile these things, then it will be system dependent. Otherwise, if we need any compiler or something else, then it would be system independent.
Very similar. Yeah, of course, you should have a compiler, but if you give me the same, if you explain the dependent and independent in that way, in the compiler way, also fine. It is also okay. But think about our application software. Do they have any compiler?
No, sir.
Then you are using Zoom. Zoom have any compiler?
Again, sir, assembly language has not any compiler, but this is system dependent.
Yeah, but they don't have any compiler, but they have an assembler which actually converts your code into the machine language code.
Okay, sir. Okay, sir. Thank you.
Right. Okay, fine. Thank you, everyone. Allah Hafiz. See you tomorrow.